So we're going to dive a little deeper into types of covalent bonds, because we can separate these into two major categories. And it's all based off of electronegativity. So the first type of covalent bond is a nonpolar covalent bond. Now, a couple of things don't change. First off, electrons are shared. That's every covalent bond. Second off, it's between nonmetals. That is true. That doesn't change. The difference is how the sharing occurs. So, when you're a kid, like I once was, and you share video game controllers, especially if you go over to a friend's house, there are two ways that friend can share that video game controller. Evenly, meaning one person plays a game, then I get to play a game, and then my friend plays a game, and then I play a game. My friend, and then me. This 50-50 split of video game controllers is basically what a nonpolar covalent bond is. We're just going to replace the controller with an electron. And we're dealing with an even sharing. The only way for there to be an even sharing of electrons is if there's an equal pull of electrons from both of the atoms. And the word that we use to describe the pull on an electron is electronegativity. And so if the difference in electronegativity is 0, that classifies a nonpolar bond. And this typically happens when you have, that came out really gross, hold on. This typically happens when you have the same element. It's not exclusive, right? But anytime you have, for example, when H is bonded to H, one H has an electronegativity of 2. The other H has an electronegativity of 2.2. They're the same. So the electron can't choose who to spend more time with. So it splits its time 50% and 50%. It's an even sharing of electrons. Now at higher levels of chemistry, at college or AP Chem, the difference kind of moves its way to being anything that's less than 0.4 is classified as an even sharing and a nonpolar bond, right? But as far as New York State Regents is concerned, the way they ask questions is this will only show up as an electronegativity difference of 0. Now, if you're at your friend's house and they're sharing 50-50, that's great. I'm happy. I'm happy for you. I'm happy for me if it gets to be me. But the unfortunate thing is there's one other type of sharing, and that's the uneven sharing of electrons, or the uneven sharing of electrons. Again, in this polar covalent bond, electrons are shared, and it is always between nonmetals. But the difference between polar and nonpolar is that there's an uneven sharing. 60-40%, 30-70, 95-5. There is a sharing that is not 50-50. Right? A video game controller, it's I get to play a game, my friend gets to play 3. Then I get to play a game and my friend plays 3. It's not an even sharing of the controller. And in a polar covalent bond, it's not an even sharing of an electron. The only way this happens is if there is an unequal pull. Right? If one atom is stronger than the other atom at pulling electrons. So we're looking at an example down here. Fluorine has a 4.0 electronegativity. Hydrogen has a 2.2. In comparing F to H, F is very strong. H is very weak. And so the electrons, they sense that. They sense that electrostatic charge, that extra yank from fluorine's nucleus. And they get pulled over there more often. They hang on the side that is more electronegative more often. And this creates an uneven sharing. It also creates an interesting dynamic of the electron within the bond. And you got to ask yourself, if you understand that the electron is pulled to fluorine, and if you understand that electrons are negative, then this side of the bond, right, this side of the bond is going to be a little bit more negative most of the time. It's not going to be fully negative. It's not going to have a full-blown negative charge because sometimes that electron, goes back that way. It doesn't stay there for very long, but sometimes it does, and then it comes back. So we call this strong side of the bond the partial negative side. And if that happens to be the strong side of the bond, we'll call the weak side of the bond the partial positive. That's gross, but it's okay. Wherever the electrons aren't, that space tends to be a little bit more positive. So the hydrogen becomes partially positive, the fluorine becomes partially negative, and both atoms are happy because they have an electron configuration that seems to be 8, but not precisely. So that about wraps up polar and nonpolar covalent bonds. I hope you enjoyed, and catch you in the next one.